In this video, we'll present how we've used the Raspberry Pi and Java in order to build a smart remote control.
Hello, I'm Olivier.
Hello, I'm Elisenda.
Hello, I'm Jerome.
We are
Java
Developers.
and we've worked
together
On the
Smart Remote Control.
First, a bit of vocabulary about the context. STB stands for Set-Top Box. This device is dedicated to deliver IPTV and related service to our customers. This is a device with embedded systems constraints such as low memory, disk or CPU capacities. On top of the hardware layer, there is a Linux systems with dedicated drivers, a lightweight web browser, and finally a SDK and HTML JavaScript application. That's where we code. In fact, a STB is just a web browser that displays HTML pages stored on the device to deliver services. The only difference is that you browse the services with a remote control, not a mouse or a keyboard.
According to everyone, these steps consume too much time and we need to do something. In fact, we need to make a machine work for us. Our objectives were mainly to find a solution that meets two criteria: improve our productivity and improve our quality, with a simple and low-cost solution in order to spread it quickly. But on one side, we have a device with just an infrared interface. No way to improve it. And on the other side, we have developers' tools that don't know how to deal with infrared. To solve this problem, we've used a Raspberry Pi in order to create the glue between these two worlds and provide a synchronous HTTP interface over the system. With a card, we've added infrared I/O to the Pi. The Pi then becomes the HTTP entry point for the STB, providing interface to trigger infrared key or key sequences from my HTTP call. Now, this architecture opens the infrared world to the test tools on a simple PC. And thanks to a little hack on the STB side, we are able to launch an IR signal and retrieve the dump structure of the displayed page on TV. Let's see a typical scenario. The PC initiates a request to the Pi. The Pi requests STB by infrared. The STB executes the action and sends back the DOM to the Pi. The Pi uses this response to finally answer the PC HTTP request.
Let's take a closer look at the architecture. On a design point of view, our solution is quite simple. A Raspberry Pi, a simple electronic card, and some open source software components. We've used standard components such as PHP, Apache, and of course Java. To do the job, we've integrated two libs, P4G and Lirc, in order to work with the GPIO. The core element of the solution is a Java engine that runs infrared sequences. This component is exposed through a REST API implemented in Java 8 running on Tomcat instance. PHP pages are just here for administration purposes. The sequence managed by our tool is rich enough to reproduce the customer's use cases. We provide mechanisms to send infrared, delay, repeat instruction in loops, reboot electrically, etc. The first prototype looked like this: an infrared blaster, an infrared receiver, storage on the SD card, a power relay to electrically reboot the STB. Now it's time for a demo. For this demo we have Duke, a STB, a basic TV, Raspberry Pi, and of course SSH session from my PC to the Raspberry Pi. The first step is to connect on the Raspberry Pi and launch the sequence recorder. The sequence recorder records all the events that are received on the infrared receiver. So we can play with the remote control and the STB and the Raspberry Pi that is between remote control and the STB intercepts and records all events, as we can see on the screen on the right. Now the sequence is finished. From now, we doesn't need the old remote control anymore. We will only use a PC and a web browser to access our remote control and launch a scenario, as you can see on the screen on the left. The scenario is launched from the PC, just asking for an HTTP URL. And now, thanks to our smart remote control, we are able to send infrared sequences just with an HTTP request and retrieve all the contents of the TV in a standard web browser, for instance Firefox. So now it's just very simple to do the same from Selenium IDE. We can start the test again. As you can see, Selenium asks the sequence from an HTTP request. The sequence is played on the TV on the left of the screen. We replay exactly the same sequence with the same temporizations. And the good point is that now we can do some assertions on the results. And now, even better, we can completely virtualize the remote control and use it just as a basic UI inside a web browser.
To conclude, here are some figures. The first prototype was developed in 4 weeks, over 400 functional tests developed in 3 months. VOD test takes 3 hours in the night instead of 5 working days before. Team has gained confidence in its code, a better image from customers, and access to dev environment from home, enabling telecommuting. What else? The first idea was just to reproduce automatically use cases and check the results from Selenium IDE. But our smart remote control has opened new possibilities such as robustness, monkey test, load test, debugging, retrieve the content of the STB embedded browser, create a snapshot of a defect, more accurate than a simple photo, and also remote administration of STB thanks to a serial USB connection.
Thanks for your attention, and maybe see you at the next Java one.